In this animation, we will examine the reaction of alkanes with chlorine. An alkane, for example, methane, and a halogen, for example, chlorine, react to produce chloromethane and hydrogen chloride. This is called a substitution reaction since one hydrogen atom of methane is replaced by a chlorine atom. So methane and chlorine will produce chloromethane and hydrogen chloride. One of these hydrogen atoms is replaced by one of the chlorine atoms, so this is a substitution reaction. This reaction takes place through a free radical mechanism and takes place only in the presence of ultraviolet light. So if there is no ultraviolet light, alkanes and chlorine will not react. The mechanism involves the formation of radicals which are very reactive. Let's study now the steps of this reaction. In the first step, a chlorine molecule, Cl2, splits. One electron of the shared pair in the covalent bond stays with each chlorine atom. So this red dot is the electron from the bond broken. Two chlorine radicals which are very reactive are formed, and this step is the initiation step. Actually, ultraviolet light provides the energy required to split the chlorine molecule into two chlorine radicals. So let's watch again the first step. In the first step, we have a chlorine molecule Cl2. In the presence of ultraviolet light, the chlorine molecule will split and two chlorine radicals will be produced. The next step is the propagation step, which consists of two reactions. In the first reaction, a chlorine radical reacts with a methane molecule to produce hydrogen chloride HCl and a methyl radical CH3 radical. So again, a chlorine radical will react with methane to produce hydrogen chloride and a methyl radical. In the next reaction of the propagation step, a chlorine molecule Cl2 reacts with a methyl radical to produce chloromethane and a chlorine radical. So this chlorine radical can now react with another methane molecule, so the propagation reactions alternate. So let's repeat. In the initiation step, a chlorine molecule will split into two chlorine radicals. Then comes the propagation step. In the first reaction of the propagation step, a chlorine radical reacts with methane and thus a methyl radical is produced. In the second reaction of the propagation step, this methyl radical will react with Cl2 to produce chloromethane, which is one of the products, and a chlorine radical, and so on. The last step is called the termination step. So during the initiation and propagation steps, two types of radicals are produced, which are methyl radicals and chlorine radicals. If by chance two radicals collide with each other, they will react and the reaction will be over. So let's examine how can radicals react with each other. So one case is that two chlorine radicals will react to form chlorine gas. In the other case, a chlorine radical will react with methyl radical to produce chloromethane. And one possibility is that two methyl radicals react to form ethane. So as we have noticed, when two radicals react, they form molecules, and thus there is no production of new free radicals, so the reaction will be over.